Good morning. This class we are discussing the mechanism of Reimer-Tiemann reaction. Mechanism of Reimer-Tiemann reaction. Okay. What is Reimer-Tiemann reaction? Last class we have studied the reaction of phenol with chloroform, CHCl3 and NaOH, followed by hydrolysis, acid hydrolysis, we get salicylaldehyde, that means ortho-hydroxy benzaldehyde, that is salicylaldehyde. Okay, this reaction is known as a Reimer-Tiemann reaction, reaction of phenol with chloroform and NaOH, followed by acid hydrolysis, we get salicylaldehyde. This reaction last class we have studied. And now look at the mechanism of this reaction. Okay, first I am taking chloroform and NaOH. Look at it here very carefully. So you can see that the chloroform CHCl3, Cl, Cl, Cl. Okay, this is chloroform CHCl3 chloroform. And our base NaOH is here, that means Na plus and OH minus. Our base OH minus, okay, OH minus removes this proton from chloroform. Okay, so what is eliminating? H2O is eliminating. Then what will happen? You can see that, look at it here very carefully. OH minus, our base, removes a proton from our chloroform. Then this pair of electrons, this bond is shifting to carbon. The same moment the Cl is eliminating. And what we get? Okay, we are getting what is minus H2O. H2O is removed. Where is we are getting this OH minus? From NaOH, Na plus and OH minus. This is from our base. OH minus is from NaOH. This OH minus removes a proton from our chloroform. Then this pair of electron is shifting to carbon. That means carbon. Okay, a pair of electron. Okay, and the same time what is happening? This bond is breaking from Cl. That means remaining we have two Cl. Okay, Cl, Cl. Correct? And what is also eliminated? Minus Cl minus. That Cl minus is joining with our Na plus. That means minus NaCl minus NaCl. Okay, that is clear. Now look at here, this species. This may be new to you. You can see that carbon with a lone pair electron. Carbon with a lone pair electron. This is what is known as carbene. Carbon with a lone pair electron is known as carbene. And what is the specific name of this carbene? Dichloro. There are two chlorine atoms. It is known as dichlorocarbene. So this is new to you, carbene. We know that carbon is having a positive charge. What is that? Carbocation. Carbon is having a negative charge. What is that? Carbanion. Now you can see that carbon is having a lone pair electron, which is known as carbene, and the specific name of this carbene is dichlorocarbene. Now look at here. Once again, I am explaining the same thing. Suppose the OH is removing this proton, that means minus H2O is removed. This pair of electron is moving to carbon, and suppose this chlorine is not moving. Okay, the chlorine is not leaving from this carbon. Then what do you get? C. Okay, then this 3Cl is here only. The chlorine atom is not leaving, and the bond is shifting to carbon. That means a pair of electron. Then the carbon will get a negative charge. Then the carbon is getting a negative charge because if this chlorine is not moving, that means what is happening? This carbon is getting an additional electron from hydrogen. Okay, that means both electrons are moving to carbon. That means it is getting an additional electron. Then of course, then the carbon will have a negative charge. Okay, so keep the difference between what is carbene and this is carbanion. This is carbanion. Okay, carbanion. Okay, because the carbon is having a negative charge. Now you look at here. Suppose now what is happening? This chlorine is moving. Then what will happen? The negative charge is gone. Clear? Clear? Because you can see that this pair of electron is coming to carbon. Then the carbon is getting a negative charge. And now what is happening? the CCl bond is breaking, then what will happen? That negative charge is gone. That negative charge is gone, but it will have a pair of electrons. It will have a pair of electrons. So what will happen? Now when the CCl bond is breaking, what will happen? Cl, and the negative charge is gone, but we will have a pair of electron on carbon atom. We will have a pair of electron on carbon atom. This species is known as carbene. This species is known as carbene. You can write the mechanism directly like this, or you can go like this. First, the formation of carbon ion. What is happening? OH is removing H plus. This pair of electron is moving to carbon. Then carbon is getting a negative charge with a pair of electron and a negative charge. Okay. Now what is happening? This bond is breaking. Then what is going? This negative charge is gone. The negative charge is gone because here one bond is coming and here one bond is going. So what will happen? The negative charge is gone, but what will remaining? This pair of electron will be here, and this is known as carbene. Okay, you can directly write like this, or you can go via this way also. Okay. Now this is the first step, formation of carbene. I think it is clear to you. Formation of carbene. Okay. Now, what is the property of carbene? Now look at here. This carbene can act as a electrophile. It can act as a electrophile. What do you mean by electrophile? Electrophile means which can accept electron pairs from other species. Okay, that which can accept electron pairs. That means they are electrophile. Why carbene is acting as an electrophile? Look at here. What is the number of electron on carbon atom? 1, 2. When it is making a bond with this chlorine atom, so 2, this is lone pair electron 2, and here it is 2 plus 2, 6, 4, and again plus 2, 6. What is the total number of carbon in this carbene? Only 6. Clear? Because you can see that here it is 2, then this bond is a pair of electron 4, and this is also a pair of electron 6. That means carbon is having only 6 electron, its outer shell. That means it can accept a pair of electron, because it can accept 2 more electron, then only it will become 8. That means, or we can say that due to the presence of electron withdrawing group, this Cl is electron withdrawing, and because of this 2 electron withdrawing groups present on the carbon, you can see that this carbene can act as a electrophile. The carbene is electron deficient. It can accept electron pair. It can accept electron pair. So look at here. Carbon, here is 2 electron. 2 plus 2, 4. 4 plus 2, 6. Only 6 electron. That means it can accept 2 more electron. That is the reason this carbene can act as a electrophile. Carbene can act as an electrophile. What do you mean by carbene can act as electrophile? The carbene can accept one more pair of electron from other species. That is very, very important. Okay. Okay. Now our phenol. Okay, look at here. We are our first step is formation of carbene, as we have discussed. Formation of carbene, and carbene is electron deficient. It can accept a pair of electrons. So look at here. This is our phenol. We are continuing the mechanism. Phenol. Again, phenol is reacting with our NaOH. Of course, NaOH is in the reaction medium. In the medium, NaOH is there. First, chloroform and NaOH will react, and it will change into dichlorocarbene. And you can see that same time all these reactions are happening. What is happening? Now phenol is reacting with NaOH. This is also occurring. Phenol is reacting with NaOH. This we have studied. Phenol is acidic in nature. As it reacts with a base, what will form? H2O will be eliminated, and what we get? Sodium phenoxide. That we have studied. That means we get what we get? Sodium phenoxide. That means O minus and Na plus. Of course, Na plus is there in the solution. Of course, it is there. Okay, that doesn't matter. It is not important for us. Okay, that means this is phenoxide ion. So what will be eliminated? H2O minus H2O. H2O is eliminated. And what we get? We get Na, Na, sodium salt of phenoxide. So sodium phenoxide we are getting. Okay. O minus. This is phenoxide ion, O minus and Na plus. This we have studied. Now look at here, our carbene. Now our carbene, you look at here, Cl double bond. This is our carbene. As I told you, carbene is electron deficient. It can accept a electron pair from other species. So now what will happen? This phenoxide ion, this pi bond. So this is electrophile, very important. Carbene can act as a electrophile. It can accept electrons. So this can act as a electrophile. So what will happen? You can see that from this phenoxide ion, okay, what will happen? This pi bond, that means it's a pair of electron, and you can see that this carbene can accept electron. So this pair of electron, this pi bond breaks from this carbon, and it will be it will make a bond with the carbon. It will be, this pair of electron will be migrated to carbene. Okay, the same time what will happen? O minus means it's a pair of electron. This will be shifted to here. Okay, so what we get? We get a structure like this. Look at it here. Okay, we get here this bond no change. Okay, here it is, double bonds are here. Now what is happening here? It will become double bond, and you can see that this bond breaks from this carbon, and it is joining with the carbon. Okay, this carbon. Okay, now we look at it here, C, and here it is Cl, and here is also Cl. It has a pair of electron, and you can see that in addition to this pair of electron, this is carbene only. You can see that bond is shifting, bond is breaking from this carbon, and it is moving to making a bond with this carbon, means additional electron is coming to this carbon, therefore it is getting a negative charge. Clear? This is carbene. Now you can see that this pair of electron, okay, this bond break from this carbon, and it is shifting to this carbon, means additional pair of electron is joining with the carbon, therefore it is getting a negative charge. Very important. This here you are getting a negative charge, because this pair of electron is making a bond with this carbon, therefore you are getting a negative charge. And of course you know that when this bond is breaking from this carbon you will get a positive charge, but this is compensated by this bond. When the bond is shifting to here, when it becomes double bond, there is no more positive charge. Otherwise what will happen? When the bond is breaking from this carbon will get a positive charge, but that positive charge is compensated by the shifting of this pair of electron. That means here it will become a double bond, and this bond is breaking from this carbon and it is shifting to carbon, therefore this carbon is getting a negative charge. Okay, now look at next step. What is happening in the next step? Okay, I am writing the same structure once again, Okay, here it is like this. Okay, double bond, O, and you can see that is C. Here it is Cl. Here is also Cl, and it is a carbene only. It is a pair of electron, and of course it will get a negative charge. And look at here. Here is a hydrogen atom. Correct? Here is a hydrogen atom. This same structure only. You can see that a hydrogen atom is here. So I am showing this hydrogen atom. Okay, I am showing that hydrogen atom. And in the next step, what is happening? In order to regain the aromaticity, there is a rearrangement. You can see that this pair of electron, that means this pair of electron with a negative charge, or you can see that this carbene, this will abstract, this negative charge will abstract this proton. That means this carbon will take this proton. Okay, and what will happen in the next step? You can see that this is a little bit complicated for you. This bond will be shifted to here, then here it will become a double bond. What will happen? This bond will go back to oxygen. Okay, so I am writing the structure like this. Okay, look at it here. Here it is like this. Okay, and here again it will become O minus, and you can see that here it will become a double bond. And only this H is taken to H plus, proton is taken to this carbon. Why this carbon is taking this proton? Because the carbon is getting a negative charge. Carbon is having a negative charge. Because of this negative charge on this carbon, what will happen? This carbon will abstract a proton H plus from this carbon, and what you get? A C, and you are getting a hydrogen on this carbon, and of course our chlorine is here. The second chlorine is also here. Clear? Okay, And what is happening? Here is a double bond. Okay, here it is like this. Clear? Clear? Okay, now in the next step, I think this step is clear to you. Okay, once again I am repeating. Since a negative charge is created on this carbon, this negatively charged carbon will take a proton. Here is a proton, here is a proton. Okay, this proton, only this hydrogen, that will be taken by this carbon, because this carbon is having a negative charge, and then what will happen? This bond will be shifted to here, then it will go back. Okay, so you are getting a structure like this. Okay, now in the next step, you can see that again our NaOH is here in the medium. That means Na plus and OH minus. You can see that this is like our SN2 mechanism or SN1 mechanism. What is that? Here is our OH minus. Okay, OH minus. Of course, Na plus is there. Okay, leave that. OH minus from NaOH. This OH minus, you can see that like our SN2 mechanism or SN1 mechanism. Okay, this OH minus will attack on this carbon. Okay, then CCl bond. CCl bond is a polar bond. This is delta positive and this is delta negative. Then what is that? When this OH is attacking on this carbon, what will happen? The CCl bond will break. Okay, that is via SN2. Okay, whether it is SN1 or SN2, the reaction will occur. That means what will happen? This OH minus will attack on this carbon, and what will be eliminated? Cl minus is eliminated. Or suppose this reaction is occurring via SN2, it will be like that. But it can be like SN1 also. What is that? If it is SN1 means the CCl bond will break, then what will happen? The OH minus will come and attack. Okay, first step is the formation of carbocation. Then what is that? OH minus is coming and attacking this carbon. Anyway, what is happening here? Nucleophilic substitution. Nucleophilic substitution reaction. Substitution, whether it is SN1 or SN2, doesn't matter. But what is happening? This nucleophile OH minus is displacing Cl minus, and in place of Cl, what is coming? OH is coming. That is our nucleophilic substitution reaction. Then what we will get? We get a structure like this. Okay, look at it here. Okay, this is like this. Okay, here it is no change. Here it is O minus, and here you can see that C. The OH is coming to this carbon. I am showing that OH first. Okay, OH is coming on this carbon, and the Cl is removed. There is one H and only one Cl. That means what is removing here? Minus Cl minus. Okay, minus Cl minus. This Cl is removed because the OH is attacked on this partially positively charged carbon, and the Cl is removed. That is what is called a nucleophilic substitution reaction. Of course, Cl minus is removed. We know that there is Na plus is here. Na plus and Cl minus will join, and NaCl. Okay, you can take like that. NaCl is removed. NaCl is removed. Okay, now we are getting a structure like this. Okay, we are continuing. In the next step, look at here, in the next step, you can see that this O minus, and you have OH group on this one. That means this hydrogen is delta positive. Of course, oxygen is delta negative. That means you can see that this negatively charged oxygen will abstract this hydrogen. Will take hydrogen from this oxygen atom. Will take hydrogen from this oxygen atom. That means it will change into OH. Then what will happen? This bond, OH bond, this bond will be shifted to here. That means here it will become a double bond. Simultaneously, what will go out? Cl will be eliminated. Because Cl is a good leaving group. Cl will be eliminated. So I am repeating. So the ring is like this. Okay, ring is like this. Okay, here it is double bond. You can see that this O minus is taking a proton H plus from this OH. That means here it will become OH. Okay. Now what will happen to this bond? HO bond. This HO bond will be shifted to here. That means here C. Here it will become a double bond, and here it will become a double bond. Then what is removed? Cl minus is removed. Cl is gone. So only what we will have? We will have only H. What is removed from here? Minus Cl minus. Cl minus is gone. And what we will have? We will have this one. What is this one? This compound is our. What do you look at here? We got our compound OH CHO. What is this one? Salicylaldehyde. Clear? This is the mechanism of Reimer-Tiemann reaction. The mechanism of Reimer-Tiemann reaction is important. So keep it in mind. Okay. And thank you.